This is Twit.
Bandwidth for Know-How is brought to you by CacheFly.
This episode of Know-How is brought to you by DigitalOcean. Simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com. And once you sign up, be sure to enter the promo code KNOWHOW in the billing section to get your $10 credit. And by CuriosityStream, a subscription streaming service that offers over 1,400 documentaries and nonfiction series from the world's best filmmakers. Get unlimited access starting at just $2.99 a month. And for our audience, the first 2 months are completely free if you sign up at curiositystream.com/twit and use the offer code TWIT. On today's show,
you'll know how to make your own 3D printed project.
Welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Ballecer.
And I'm Bryan Burnett.
And for the next 30 to 45, 50, 90 minutes, we're going to be showing you some of the projects that we've been playing with so you can take them home and geek out on your own. Hippo!
What's up?
How you doing, my friend?
I'm doing well. We've been traveling a lot lately.
We have, because again, he was promoted. He's my new live events producer. He's the man who comes with me to go to CES, NAB, all the cool events outside of the studio. And yesterday, we actually stopped by a local show that had more than I thought they would.
Yeah, local in the sense that we had to drive like 3 hours to get there. But yeah, it was VR and AR. So
AWE, the Augmented World Exposition.
Yeah, it was pretty neat. But you know, most of the stuff was like you had to physically experience it because when you're filming it, it's just people with goggles on or something like that.
That's the difficulty of a show like that, because I love the subject material, but I can't always have someone just filming the guy with the goggles.
Because as we know, we look so cool with the VR goggles on.
You can't help but look good when you've got HTC Vive and you're like
dancing around, DJing.
Yeah. Interesting applications for VR and AR, and we will be showing you some of the footage from that show in upcoming episodes of Know-How. But for now, I think the ones that impressed me the most were the training companies, the companies that were using AR to do innovative ways of teaching skills. There was Seabury. Seabury had that trailer that was outfitted with what looked like welding machines. They actually used welding stations.
Right.
And you would put on the welder's helmet, but the welder's helmet had a screen inside of it so that you could see. There was a camera in front of the helmet, so you could see the real world, but then it would overlay the welding material on top of real material, and then you would have your welding, your MIG or your TIG welder, and it would judge you based on your angle, your distance, your speed, and it would actually it would alter the image so it would look like you're actually welding.
Yeah.
But then when you're done, you can replay the session and it will critique you. It will say, okay, your technique was good up to here, then you slowed down, or the angle was off. That's the sort of stuff that gets me excited.
Yeah, I was watching you do that, and it's probably for the best that you did it in a virtual reality kind of setting, because you would have just like melted your hand off at the same time.
Well, there was part of it that was like it was difficult to get used to it because it was an actual MIG welder handle, and I do TIG. And I mean, it showed me, it's like, yeah, here you would have burnt through all the material.
Because you were working with aluminum, right?
Yeah, and it's like, here, we're not sure why you were welding, because like the joining was down here and you were going up and over, but okay.
Yeah, you know. The one I liked, it was a little silly looking, but it was a hard hat. It was like a smart hard hat that you would wear at a construction site, and it would show, like, if you're walking up, say you worked in like a building with a bunch of pipes and stuff, and you had to change valves and change the pressure and stuff. It showed you the direction that the pressure was moving, and it would show you like which valve that you needed to turn in which direction, and be like, this is what's going to happen if you do it. I can see the direction things are going in. But
that's a game changer. Yeah. That kind of technology. Like they had one. They had a caterpillar. I can't remember the name of the company, but we'll have the video. And what their application did was it allowed you to use either a HoloLens or like a Surface tablet, and you could use the camera and you'd see the real world, but then it would overlay schematics on top of that.
Right.
So for example, you could go to a Caterpillar that was having engine trouble, and it would link up with the diagnostic computer on the Caterpillar and say, well, we think it's this. That part of the machine would be highlighted in red, and then you could like pull it out and explode it.
Yeah.
And it would show you, well, what's the procedure for taking this apart? What should all the parts look like, so that when you disassemble it, you could say, oh, that one looks wrong.
Right.
That's the part I have to replace. That was awesome. Cool. That could shave days off of a work schedule.
Yeah. No, I wouldn't mind having that when I need to do some maintenance on my motorcycle. Like have things, so I can see the extrusion. Oh, there's a washer that I need to replace there, or I forgot that,
Now, of course, that's augmented reality, but what we want to talk about in this episode is real reality.
Augmenting our own reality with 3D printed parts.
Exactly. This came to us from our audience. At NAB, I met up with a couple of fans, and again at, where was that? The Comic-Con. And one of the things that they said was, we like the show, we love when you do 3D printing, but it's scary. And I totally get this. I get this. People are saying, is all I can do is just download things from Thingiverse and then print them, because I don't have the skill, or I don't have the imagination, or I don't know how you would go about actually making something. So these are people who they need to make that jump from just downloading and printing objects to maybe downloading, modifying, and maybe even creating things from scratch.
Yeah, because that's the beauty of 3D printing, is that you can design it for your own specific needs, which is actually pretty easy. I had a background in drafting, so that probably helped a little bit, but anybody can pick up some of this stuff.
Yeah, but what we're going to do is we're actually going to show you the process that we use here on Know How. The process that's actually, it's not just for 3D printing. This is really the process you would use for programming, for tinkering with microcontrollers. It's all based on finding something in the real world that you want to fix or you want to improve, and then somehow making it better. And in this particular case, we're going to be using the media of filament and the tool of a 3D printer. So let's get to it.
All right.
All right, so as I said, the first thing that we want to do is we want to find a real world problem. I'm going to start small. Something that actually has to do with a future series of segments we're going to have on Know How, because we're getting into the Green Geek series.
Yes, the Martian edition.
Yes.
Right?
Well, we'll talk about that later.
We'll get to that, where we grow things inside of...
We'll get to that. But what I needed to do, what I needed was a way to distill and filter plant material that has been dissolved in isopropyl alcohol. Specifically, one of the things we're going to be doing when we get to the Green Geek is I'm going to be getting lavender. We're growing lavender indoors, and then I want to be able to extract the oil, because the oil is fragrant. It can be used in a myriad of things.
For candles or something.
Soap, candles. People actually like add it to food. Essential lavender oil is actually beneficial to your body.
Okay.
But getting it out of the lavender is
difficult? You can't just grind it up?
Actually, we'll talk about that when we get to the Green Geek, but I see a lot of videos where people will take lavender and they'll like drop it into a vat of oil and like, oh, it smells like lavender now. Well, that's not lavender oil. That's oil that's been infused with lavender. What we want to do is we want to actually extract the oil inside the plant, like the pure oil.
Cool.
And there's a couple ways to do it. You can do it with steam to burst sort of the oil sacs and extract it that way. But I'm going to be doing it with isopropyl alcohol. And we won't get into the process, but at one point, I need to be able to take, say, a jar this big.
Little mason jar, yeah.
Right. So it will have the lavender in it, and it will have alcohol that I've had in there for 5 minutes to try to get the oil out. And then I'm going to need to sort of strain it. I'm going to run it through like a cheesecloth, and then I'm going to run it through a coffee filter to get all the fine bits of plant material out of it.
Oh, okay.
Now, funny thing is I've seen on YouTube, some will like use a big mason jar and then they'll hold it for like the 20 minutes it takes for all that stuff to strain out. I'm not
worth it.
Not worth it.
Pain.
I just thought there should be an easier way to do it, and I thought maybe I could just take 2 of these, because these are relatively inexpensive, and design some sort of system that will allow me to put one on top of the other, and then it will be on some sort of agitator that will just slowly rotate it to like let that material drain through the filter.
But you'd need some kind of 3D printed part for that, right?
You would. So that's our real world problem. Our real world problem is to find a way to mate these 2 bottles, which will then be used in a future system of rotating them slowly.
Cool.
Okay. Now, I could, if I wanted to be super jank, I could just take like duct tape or some sort of adhesive.
What doesn't duct tape fix, right?
Exactly. And cap these things together like that. And that would kind of work. That'd be my double-ended adapter.
Yeah.
But what we want is, when we're designing,
To be able to rotate it.
we want to be able to rotate it, and we also want a design that can be approved upon. Because I want to take something and then say, oh, you know what? It could be better if I add this,
Right.
a vent hole. It would be better if I added another intake so I could push more material in there if I needed to.
So you're saying this is going to be a prototyping process?
It's a prototype, right? So what we are doing is we're doing the prototyping process that goes hand in hand with 3D printing. All right, let's go it. The first thing I want you to do, beg, borrow, and steal as much as you can. Especially in a world that's exploded like 3D printing. There's a lot of templates out there that are being offered for free by enthusiasts like you that you can download. You don't need to reinvent every single part.
Right.
That's one of the keys to getting into the 3D world. If you think that you have to design everything from scratch, it's an incredibly daunting task.
That feels very overwhelming. Yeah.
Very overwhelming, not so much fun, and honestly, there's a lot of people who just get turned off by the idea of, oh, I don't know where to start. Well, if you download something that maybe gives you one piece to the puzzle, then...
You can build and improve on that, yeah.
Precisely. So, what we need is we need something that will fit onto the top of this ball mason jar. And you can get these from Amazon. I got a pack of like 12 of these for $6.
Yeah.
Very inexpensive. And so I figured there's probably something out there that was already designed to mate with a ball mason jar.
Yeah, probably somebody probably already made a cap or something for it, yeah.
Yes, and the place that we're going to go to find it is Thingiverse. Alex, if you go ahead and go to this computer here, see what you're going to find is at Thingiverse, this is probably my favorite place. Again, enthusiasts just like you, people who want to create things. And so I'm just going to put ball mason. It's a big enough brand where, oh, how about that? So there are people who have already created a mason jar lid. Now the reason why this is important is if you look at the inside of one of these jars, you see all those ridges?
The threading for the
threading?
cap. Yeah.
That's going to be very difficult for us to do in the tool that we've been using, Tinkercad.
Yeah, I would not be able to do that in Tinkercad.
Precisely. So what we want is we want to take the pieces that have the fine detail, get them,
And then add to it.
Add to them, modify it, change it. So we can do sort of the brute force parts of the design, the fine pieces that made up with existing materials. If you can find a good design on the internet, get it modified. In fact, most everything on Tinkercad has been sort of, it's like a Creative Commons for design. Attribute it, let people know where you got it from, and then when you're done with it, go ahead and re-upload it so someone else can take it and improve it.
Yeah, totally.
Now this is not the one I actually went with. The one I went with was this. This one was by Old Wizard. So Old Wizard, thank you very much. This is a screw jar lid for a pint or a half pint wide mouth ball or mason jar. So pretty standard. We downloaded this, and this is actually, if you switch away from this really quickly, Alex, this is what it looks like. And again, we're going to make this, this will be available to everybody who sees our show notes. Again, switch back. This is what the design looks like. So I've got my mason jar end cap. This allows me to visualize what it's gonna be when my final print is done. And actually, I printed it, and this is what it looks like. So this is the cap that's going to go on top of that jar. This is as downloaded. That's what would print up. Now, Brian, do you see a problem there, maybe?
There seems to be a bit of a scaling issue here.
Yeah. Okay, so maybe this is a 16-ounce jar, and this was designed for an 8-ounce. That could be a problem.
Looks like you may have solved this problem.
I did, and believe it or not, it was really, really simple to solve. Let me go back over to Tinkercad, and you're gonna see exactly how we did it. Let me create.
So you didn't just search for a whole new model? Did you expand it? Did you scale it up?
I'm going to show you exactly how we did that. We had to scale it up, but I didn't want to do it by eye because if you do it by eye, what you end up doing
is printing a lot.
You print a lot, and you'll have like 30 that you throw away, and one that's good.
Very wasteful.
Instead, what I did was I measured what the mouth of a 8-ounce jar looked like and what the mouth of a 16-ounce jar looked like, and what I found out was the math was 125. So 125% of the original would fit on the 16-ounce jar.
Nice.
And Tinkercad actually has a way to do that. Alex, if you go ahead and go back to Tinkercad, if you choose the file, so we're going to go ahead and jump in here. This is the file that I downloaded, the wide mouth jar lid with jar lid landing. Okay, so do that. If you zoom in on this, Alex, I don't know if you can get in on that. Or I could just, there we go, that's better. I'm going to say my scale, instead of 100, is 125, and I'll import it. And what I'll get, as soon as it's done uploading, is this. This is actually the right size. So this is what a scaled up version of that jar looks like. And just to show you that it fits, this right here, this is my model.
Nice.
Ta-da! Nice and secure.
Perfect.
Okay, but so far, all we've done is we've recreated the lid that already came with the bottle.
Right, which isn't that
Not
helpful.
super effective, not really helpful.
But it's gotten us past the really hard part, which was the threading.
Exactly. And again, remember, this is important. We have a pre-designed part that lets us attach to something that I can buy, something that's mass-produced, which I want, because one of the worst things that you can do when you start tinkering is to make proprietary sizes and proprietary products so that you can, if you break a part, you can't, it just destroys the machine.
Right.
In this case, since I can always order these jars, I know that even if I break them, I'm going to be able to buy a replacement really easily without having to recreate it.
Right.
Okay. But now I need some way to make this attach to that. Any ideas?
I would take the original model and flip it over and put a hole in it.
Okay, let's try that. That's a very good idea. So what we're going to do, Alex, if you head back over here. So I've got my design. I want to put another one of these on top, which means I'm going to have to flip this over. So I'm going to select the item, and you'll notice there's these little, on three corners, these are actually rotation features. So this allows me to flip the object in all three axes. So I'm going to flip it 180 degrees. 180, there we go. So now it's bottom side up.
Right. Now, if you just tried to print it like that, though,
It's not going to work.
not
We'll
work.
explain that. We'll explain why it's not going to work. But now what I need to do is I need to import another one at 125 scale. So import. Superman. And then I'm going to take the second one and I'm going to drag it up. And now look at that. I've got two. One is bottom side up. The other one is right side up. And I'm going to just barely kind of kiss the two pieces like so. There we go. So now they're actually touching, but I need a way to get through this.
Right.
So what I'm going to do is I'm going to go back to the shapes. I'm going to create a cylinder. I'm going to drop a cylinder. Actually, let's make this a bit bigger, make it easier to see. I'm going to drop a cylinder. This is not perfect, but just about dead center. And then I'm going to make it a hole.
Right. A void section.
Right. And remember, we talked about this before. One of the coolest things to do in 3D is you create something and then work with negative space. So this is our negative space, and we're going to, again, this is not going to be perfect, but I'm going to drag it out to more or less fill what I want. I can make that bigger or smaller based on how much material I want to drain out through it at any given time.
Right.
So this is actually ready for me to export, but there's a problem, and you mentioned the problem before. What do you think that's going to be?
So 3D printing starts from the bottom and builds up. If there's anything that overhangs on the section, it won't have anything to support it. So you either have to have rafts, is what they're called, or raft is actually the little bottom part, but supports.
Yeah, the supports.
Yeah, you'll have to have like little supports that need to get built to hold that stuff up.
Yeah.
Which I don't know if that would work for this design.
It might or it might not, but here's the thing. Some software, like the software that came with my DaVinci Junior printer and the software that came with the MakerBot that you're using, will automatically generate supports.
Right.
You can just click a button and it will analyze it. A lot of software won't. Tinkercad actually won't do that. And the software that I'm using for my idea builder, my Dremel, that doesn't do it either. So I need a way to make sure that this will print properly, because as you mentioned, a 3D printer can handle a little bit of overhang, like 1 or 2 millimeters.
Right.
But if you have like a 30mm part, it's just, there's nothing on which it can print.
And there's nothing more disappointing than setting your model that takes about 12 hours to go, and you come back 14 hours later, and it's just, collapsed inside of itself.
Did you have that happen to you, Brian?
Why would you think that? Yes, I did.
You did. All right, so what we've got is, I've actually exported this. So I'm going to download for 3D printing. Here we go. I'm going to make it an STL, and it's going to wait forever for Tinkercad because that's what Tinkercad does sometimes. There we go. All right, so we're going to drop it on the desktop. And then I'm going to open up another free piece of software. By the way, everything that we're showing off on this episode is free. You don't pay for Tinkercad, and you will not pay for an Autodesk product called Mesh Mixer. Go to my computer. This is what we're going to open up. This is a free piece of software from Autodesk. Don't restore. And what it will allow me to do is, this is actually a really good piece of software. Let's go ahead and import it. And we've got it on the desktop. This is the file that we just exported from Tinkercad. And what we need to do is we need to tell the Mesh Mixer, take a look at this and tell me where this is not going to print properly. And it has a little button over here called Analyze. And if I click Analyze, and then I say Analyze for overhangs, it will go through and it will say, okay, look, the blue is okay. They're overhangs, but it can deal with it. But if we zoom in here and take a look at the underside, you'll notice, oh, that's the red. The red is no bueno. And what that means, actually, let's get in a tiny bit more. It means when it goes to print that overhang, that's going to be problematic. It's not going to like that. It's going to actually fail out really poorly.
There's the real red.
See all that? So the entire bottom surface of that flange, of that adapter, is not going to print properly. Luckily, what Mesh Mixer will do, if you click Generate Support, is this. It's going to process all the nodes. It's going to see how far can I get before I require an overhang, and then it will automatically generate what it needs. So take a look. Let's get in here.
Oh.
This is, there we go. So it's created all of this all the way around the part. Now, that looks funky, and people are going to go, why is it all...
Why does it look like little trees holding it up?
It's because this is not only generating overhangs, which is what the MakerBot software will do, and the XYZ software will do. It's making me overhangs that will be easy to break off.
Exactly, yeah.
And this kind of form is actually, it's much better than doing a straight column. A straight column in a 3D printer doesn't work really well. This sort of tree structure not just gives me enough support to create that overhang, but it also means when it comes time to remove the print,
you can just break it off.
I just remove them with my finger. I just snap them right off. So if I export this now, it will export as an STL, and then I can use whatever software that I'm going to be using in this particular case.
It threw one on the outside.
It didn't like that.
I wonder if you can individually remove the structures if you needed to.
Yeah, and actually in the real design, let me show you what the real design looks like. Replace. So the one that I did, and the one that you will be able to download, again, with our links, is this. And what I did was I actually added panels to the outside to sort of made them up better. And this is a much bigger hole than you had in that other design.
Right, so less of an overhang.
Correct, correct. So this is what the finished product looks like. We went ahead and printed it, and this is our mating adapter. So
we started printing at the beginning of the show, and now it's done.
Yeah, I know, right? Yeah. We've got a really good 3D printer, folks. There we go.
Perfect.
It's a perfect mating. Now, what we will have to do is we will have to do something with these parts. These are the seals for the jar, because otherwise it's going to leak around the edges there.
Right.
But what Burke did for us was he burked it.
Oh, yeah, he put holes in it.
He just put holes in it, and it's actually nice because this allows us to have a little bit of support for whatever material we're using to strain, like a coffee filter.
Right.
And it does work, but this is not my finished product, because what I will want to do ultimately is I want to keep the top side open a little bit, because if you don't vent it, what's going to happen is you're going to develop a vacuum in the top cylinder, and it won't drain as well.
Yeah.
Right. So I've already got that, but we're going to hold off on that until we actually get to the Green Grow series.
Yeah.
So this is from start to finish, from idea to execution, how the prototyping process works. Now remember, when you do your final product, that's probably not going to be the final product. You're always going to find ways to improve it after you test it. For this, I found out that the vacuum builds up too much when the material gets down to about here. And I don't want to waste that much material, so I'm going to find out a better way to get pressure up into the top of the vessel.
It's an evolution.
It is an evolution. But what I like about this whole process is it engages people who like doing problem solving.
Right.
And even this, I love the fact that it didn't work the way that I thought it was going to work, because it means I get to go back and say, hey, you know what? I'm going to elongate this chamber, and I'm going to put a pressure release. And because this is beveled, I've actually already built a machine that it will hold the two jars at an angle, which is what you want for straining, and it will slowly use stepper motors to rotate it like this. It would kind of like just baby it a little bit.
Yeah, I like that idea.
Right?
Nice.
So we're going to be automating a lot of our extraction process because of the power of 3D printing. How do you like that?
I like that a lot, you know, and I like that your mentality is when you run into a problem, it's just another opportunity for you to figure it out.
Exactly. Yeah. I mean, that's what it should be for makers. Every problem is just a chance for us to geek out a tiny bit more.
Nice.
Yeah. Now we have one more project that we're going to be showing you in this episode. Bryan actually designed something for a little GoPro type action camera
stuff.
Yeah.
No big deal.
And again, we're going to take something that he had that he was able to download, so he got a reference for a mount, and then he modified it to fit his purpose. But before that, you know what I want to do?
What's that?
I want to thank a sponsor for this episode of Know How.
Oh, yeah, we should do that.
Yeah. And of course, I can think of no better sponsor to use during this episode than DigitalOcean. Now, DigitalOcean is the best way for a developer, for a designer, for anyone really who wants to get on the internet to actually get on the internet. Us old people, you know, of a certain year, we understand what it was like way back in the past when you tried to get something up on the internet. I mean, yeah, you could contract out with a hosting service, but if you wanted something to actually be a service on the web, you needed to get a colo. You needed to get a bandwidth provider. You probably needed a maintenance contract to make sure your equipment inside the colo would stay up to snuff. You could do all that still, or you could just use DigitalOcean. DigitalOcean is a new type of hosting provider that uses droplets. These are virtual machines. These are containers that allow you to put in everything you need to run your app, your service, your website, your portfolio, whatever it might be. Now, DigitalOcean is used by over 600,000 developers, including Twit's Randall Schwartz, Aram Newcomb, and myself. It lets us deploy and configure our droplets via a streamlined control panel or a simple API, and we get to choose our OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, FreeBSD. We could also select from one of the many pre-configured one-click installs, like a Drupal, Docker, or Node.js. That lets us get up and running quickly, or we can modify our infrastructure to get exactly the kind of network that we want, because they give us root access, and they give us global distribution with data centers around the world all running 100% SSDs. It's highly scalable, which means you could start small. You can start with, say, an instant, a droplet that runs for a few hours so you can test it. And once you know it can stand the rigors of the real world, you click a slider and boom, you're deployed around the planet. You could also use advanced features like floating IPs for high availability, private networking, and automated deployments via API. And they've got an extremely active community. This is one of the things that I look for in every company that I use. If you've got a user group, a support base that loves the product enough to come back time and time again to help out the new people, it means that this is a community, this is a company that you can trust. And for me, that's DigitalOcean. It's so easy to get started that you can deploy an SSD cloud server in as little as 55 seconds. Why not try it? And actually, let me give you one more reason to try it, because we're going to let you try it for free. DigitalOcean has incredibly affordable and straightforward pricing, with servers starting at just $5 per month. And yes, there is also hourly pricing available, starting at less than a penny per hour. But we're going to make it so that you can get started today and deploy an SSD cloud server for nothing. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code KNOWHOW for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do for you. That's DigitalOcean.com, DigitalOcean.com. And once you sign up, enter the code KNOWHOW in the billing section to get your free $10 credit. And we thank DigitalOcean for their support of Know How. Now, we're going to get to your project in just a bit, but since we've been using Autodesk tools, both Tinkercad and Meshmixer are both Autodesk, I thought we should take a gander over to NAB because we had a chance to speak with an Autodesk representative, and, well, what he had to say about the future of 3D modeling was more than a little interesting.
At NAB, it's not just about hardware, it's about the content. And today's content, well, it has a viewer with a more discerning taste. You need to make sure that your colors are right. You need to make sure that your 3D is pure. You need to make sure that's engaging, which is why we're here with Mark Hemaker. You're from Autodesk. Autodesk is synonymous with tools used for animation.
That's right.
For 3D. Not only that, it's also synonymous with tools used for 3D creation, for, say, what we do with 3D printing. But you're here to talk about the content side, specifically about the tools that you've created for creating immersive 3D worlds. Tell me a little bit about that. If I were to talk to some of my students in San Francisco and say, this is the tool you should start with, what would be the one you would introduce them to?
I think 3ds Max, for example, is a good starting place. A lot of people learn 3ds Max as a 3D application first, or Maya if they're thinking about visual effects. Those are kind of the core products that are at the, I hate to say higher end because they're very accessible, but I think those are kind of the core products to start with. But what's interesting about Autodesk is we have a very broad product line. And what we've tried to do is we're all about creating and making stuff at all these different levels. But across our company, a lot of that core technology is kind of spread through our different products.
When I'm looking at Autodesk and I'm looking at 3ds Max, I'm looking at Maya, I'm looking at Flame, what's the difference? I mean, how would you determine which tool to use for which job?
Well, I think to give you the high level, so 3ds Max and Maya are both 3D applications. They have different areas of focus and different industries in which they're more widely adopted, but fundamentally they do a lot of the same things. They create models, they animate, you render out final elements, whether it's for visual effects or a full animated piece, or even creating content that you're going to 3D print later. So if you're thinking about 3D creation and that kind of meticulous process of making something in a virtual space, that's a starting place is a 3D application. You have to create that somewhere. If you look at a tool like Flame, that's more, we call it finishing, which is it's not really a made-up term, but it's not you have to think about what that means, because finishing means it's the visual effects, it's the compositing, it's taking video and putting CG elements over it, it's adding the color grade, so it's finishing the whole thing. So, I'd say 3ds Max and Maya are a little more specialized in terms of creating that, whereas Flame's more of a broader tool in terms of finishing, but they're both super creative. I come from an editing background, so Flame is great for me because I respect 3D, I love it. I don't have the patience to model and animate because it takes quite a bit of time and dedication. In the same way, those guys that are use Max and Maya, they're digging in and creating this unbelievable stuff. Now, at the same time, we have this broad range of tools and products around it. So, for example, we have a game engine. So if you want to create something and then bring it in and create a game or a playable level, you can do that in our Stingray game engine.
Actually, I think Bryan has some slides from the Stingray game engine, and it's an amazing environment because once you've started creating the world, you could just as easily use this to push it over into VR if you were thinking about designing something for, say, the Oculus Rift or for the HTC Vive. You're taking these tools that are used more for artistic types and giving us a seamless transition into game development.
Absolutely. So, in terms of making games, like if you're using Maya, for example, you can just send a scene right into the game engine and slide, and you can work with it. So we want to streamline and make that easier. We have architects that are starting to get excited about some tests we're doing of taking their model from Revit or Inventor, and now you can walk through it, which is pretty cool. At a business perspective, you look at what the big studios are doing. They want to create content and create these immersive worlds, right? So you don't just see the Avengers movie, there's a game, there's a comic series, there's this kind of world building. But I think the better story, for me as a creative person and for a student getting into this industry, it's that you're not limited because you can't access things, not just financially, but because everything works together. And it's like getting the technology out of the way of being creative. And I think that's why, what's great about the internet is it's let us communicate. And what I love is seeing the explosion of content that people create that they're just doing it, and now they have a broadcast channel for it. And that didn't happen 10 years ago. You couldn't get your content out there. Not only was it harder to make, but it was harder to show off. And now all of that's happening, and we really take that to heart in how we create our tools and how they work together.
It's no longer just okay to have 3D. I remember the very first time I saw, I'm not sure what tool it was created on, but it was called Alien Song, and it was an alien dancing to Gloria Gaynor's "I Will Survive." And that was one of the first viral videos. It spread across the internet. Everybody loved it, and we were blown away that someone could create something like this. Well, that won't cut it anymore. I mean, your 3D models have to be beautiful, and they have to be seamless. In fact, Bryan, you've got some examples of tools, your tools being used to create these beautiful immersive worlds that are created element by element, and then the camera can be flown through that world. In your experience, what is the uncanny valley as far as 3D is concerned? So how real can you get before it's too real? Or how real do you have to get in order for people to accept it?
Yeah, I think part of it is there's a dedication to learn how to create work that the professionals do. I don't think that means you have to be a professional. The examples you're showing, we see people doing things that are unbelievable. They put out this content just on the internet because they wanted to figure out how to do 3D camera projection and take old photos and bring them to life, right? I think what we've reached is a point where we sometimes say people don't notice CG anymore. I think people will always notice bad CG.
Yes.
I think people will notice what good CG can do, which is bring a character to life. But yeah, I don't know. I mean, Uncanny Valley is certainly a problem in creating the realistic character. That's always difficult. And I think that technology, we haven't solved it. I don't think anyone's really solved a way to make a realistic character that doesn't trigger whatever in your mind makes people worry that that person looks sick. But we're working on that as well. And Maya's used to create some of the most realistic characters in the world. The games with the cutscenes that come to life where characters are, you're kind of living in a cutscene and then you move right into the game.
Right.
It's all part of storytelling. A great example, so I come from an editing background. I always liked the process of taking footage and putting it together. I spoke to a Maya artist and I love what he said. He said he started out in editing and it wasn't good enough because he wasn't happy just cutting shots together. He wanted to tell a story that he could create the world and place the camera in it and get the end result. And for him, a hyper-realistic result that you don't notice is CG is great because he's excited that you bought into his story. So I think that's part of it. And I know that little cliche, it's all about storytelling, but it really is. Like, that's why we want these immersive experiences. Like, I love VR. The headset's great, but it's not about wearing a dumb headset that makes me excited. It's the smile comes from the fact that I'm experiencing something that takes me out of the world I'm standing in.
Right.
So.
We've been speaking with Mark Hamaker from Autodesk. Mark, we're going to make it even better for our audience because I know right now we have a lot of students who are listening to us. And you actually have a pretty good offer for students to try your tools.
Sure, yeah. I mean, for us, it's all about students. Like, we want people to be able to access our tools. We don't make money off of students, right? And we actually make all of our software available for free to students. So I think, just anything you'd want, whether it's 3ds Max or Maya, I mean, you can start at Autodesk.com. You can go to students.autodesk.com. We make it really easy. Sign up with your student email, and you can access all of our software for free. We have plenty of training content and other things. It's kind of the best kept secret. Like, we don't want it to be a secret, or the worst kept secret. I don't know what it is, but I don't want it to be a secret. We want all of the students to use our software and create amazing stuff and then show us what you made with it, because we're always blown away with what people can make.
Exactly.
This was actually one of the topics that we saw at Augmented World. And it's this idea that we're moving from a 3D experience, a virtual experience, or an augmented experience just being a cool rendering, to it being the actual 3D files that were used to create a device. Like, for example, seeing an engine, but not just being a 3D picture of an engine, but it's interactive. So I can pull out a piece and explode it, and it uses the original CAD files, the original 3D design files, so I can see what the part actually looks like. I can take it and I can rotate it. Whenever you create something like that, so Autodesk goes from simple 3D/2D creation all the way up to the virtual engine,
right.
It makes a more immersive world.
Oh, absolutely. And I think one of my friends who is like an auto mechanic would love to have the ability to, like, instead of taking the whole motor apart to try and diagnose a problem, maybe go into like a 3D extrusion and be like, so these are the parts that wear down. This is probably the one we're looking for. Now let's take it apart and search just for that one thing instead of like pulling everything out.
Yeah, and that's where we're getting to. It's going to be a world where you don't have to recreate a device multiple times in different types of media. So I don't have to use one software and one set of tools for 3D printing, one software, one set of tools for editing, and then one software, one set of tools for rendering.
Right.
It will all be the same suite, and the same file that I used to 3D print will be used to make the movie that has that in there. I mean,
that's cool.
I mean, that is a paradigm shift. Imagine if every CG element that you saw in a major motion picture could actually be broken apart into its constituent pieces.
Ooh, or even like freeze frame and just rotate around the model and look at all the detail.
So the next Fast and the Furious movie when a car explodes and you actually have real pieces spinning in midair in a fireball.
And you say pause, and then you flip around in the scene and see all the different explosions.
Okay, now we're getting crazy.
Yeah,
Okay, stop. We will be getting back to the 3D printing goodness. Actually, Hanky Crippo,
Hanky Crippo.
Yep. He's going to be showing off a couple of the things that he's created. Kind of cool stuff. But before we do that, I want to talk about one of our newer sponsors who I've been using over the last couple of weeks, and I've kind of gotten hooked. It's almost matched up my my online viewing time for my old services.
I know exactly what you're talking about.
Of course, I'm talking about CuriosityStream. Now, are you a geek?
Yes.
Do you thirst for knowledge?
Yes.
Do you hunger to fill the knowledge hole?
Absolutely.
Well, you know what? You should fill it with documentaries. You should fill it with how-tos. You should fill it with the content that you scour the internet and your cable channel or your satellite programming to find. You know what I'm talking about. I'm talking about documentaries on the Big Bang or the latest TV series that shows you how things work, or inspirational talks from people at, say, TED events.
Folks, or Cities of the Future. That's the one I was just watching.
Yeah, and I love the fact that this vendor, CuriosityStream, has so many different titles and so many different genres, but they all appeal to geeks. Now, CuriosityStream is the world's first ad-free nonfiction streaming service founded by John Hendricks, the founder of Discovery Communications. It has over 1,400 titles and 600 hours of content available in 196 countries around the planet. They're available on many of the platforms that you already use. The web app, Roku, Android, iOS, Chromecast, Amazon Fire, Amazon Kindle, and Apple TV. They give you a wide variety of science and technology content, plus nature, history, and many more topics. It's over 50 hours of 4K content, which they've just launched, which makes them one of the largest 4K libraries on the internet, and a great way for you to test out that new monitor or TV. Now, in addition to those documentaries that I love so much, they also have interviews and lectures, including things like Stephen Hawking's Universe. It's a series where Stephen Hawking traces the history of astronomical theories and technology. The Next World, featuring Michio Kaku, talking about the future of technology, virtual reality, artificial intelligence, and other big technological questions. They got things like The Road to the Singularity, which is a Jason Silva piece. He and other experts explore the inevitable arrival of superhuman intelligence in a CuriosityStream original, only available there. They have monthly and annual plans available, and plans start at just $2.99 a month. That's right, less than $3, less than a cup of coffee or the cost of one title on a competing on-demand platform. Folks, if you are a true geek, if you're a nerd, if you are always lamenting the fact that your favorite streaming service doesn't have the content that you actually want in your brain, then you owe it to yourself to check out CuriosityStream. Check them out at curiositystream.com/twit. That's curiositystream.com/twit. And use the promo code TWIT during sign-up to get unlimited access to the world's top documentaries and non-fiction series completely free the first 60 days. That's 2 entire months free of one of the largest 4K libraries around. Again, just go to curiositystream.com/twit and use the offer code TWIT at sign-up. Feed your brain with the stream, CuriosityStream. And we thank CuriosityStream for their support of Know-How. All right, Bryan, we've talked a little bit about straining plant material. We've talked a little bit about immersive 3D environments. But what I really want to know is, how are you holding up your Nintendo DS?
From extensive research and prototyping, I was able to develop a stand for my 3DS.
Whoa, look at that. Okay.
Well, and to illustrate kind of the process of, because I think we had a 3D printer for a couple of weeks before I even did anything with it, because I was like, well, what am I going to do?
Well, no, so you were at where some of our fans were, which is, I don't know what to do next. Do I just download things? How do I make stuff?
Right, and so that's, when I first got my hands on the 3D printer, the first thing I did was I downloaded a Tom Servo. And I made a little Tom Servo, and I didn't create this, I just downloaded it. But then, one of his arms fell off.
Aww.
Because I didn't have rafts turned on, or I didn't have the support structure turned on, so his arm was not supported.
Supports are important.
Then I learned my lesson on that, because now Tom has just one arm. But so that's like an example of like, you download something and you just print it, just to see how everything works. Then I went into the process of, well, I have my 3DS. I'd really like a stand for it, something that could sit on my nightstand. And so I created something from scratch. And I started with just a base plate, and then I made these little support structures, and I threw a little bit of design. I actually downloaded a little, another 3D printed thing that somebody had made, and then shrunk it down so that it fit on the base. Okay, so yeah, the very beginning, I downloaded a couple things from Thingiverse, Tom Servo, my little friend here. But then I started designing, hey laptop, slow down. I started prototyping. So I made this was my first stand, then my version 2, then version 3.
Let's make a note here. This is actually important. The revisioning is something that you should do. I know a lot of people just want to use the same file over and over.
Yeah.
But it's nice to be able to go back to a previous version in case your new design doesn't quite work out.
Well, yeah, exactly. And that's what happened, is I started modifying it, and I changed the angles of some of the stuff, and I didn't like it as much as the previous one, and I had already, modified it. I didn't have the old version, so then I started doing the revisions. And then finally, it led me to what I designed for the GoPro was, this is a mount that I needed when we got the Ricoh, I think it's the WG action cam that I had to review. And it was a cool little action cam, but it didn't come with any mounts.
That was very surprising, because if you're going to have an action cam, it needs to be mounted in action.
Right.
And to have an action cam that is just the unit, that was a little strange.
It was a little strange. The action cam, it had a standard like tripod 1/4-inch screw mount on the bottom, but no mounting hardware. Well, I have a GoPro. That's what I was going to review it against, and I have all these mounts for GoPro, so I was like, there's got to be a way that I can like make something for it. And well, that's just for the GoPro. That was something I downloaded. What? It's very,
no, it's fine. It's fine.
Very delicate. Be careful with that. So if you go back to the screen I have, I printed out this little platform, but the actual part where it mounts to the GoPro, that I had to download from a previous drawing that had already measured out the GoPro like standard mounts. And I didn't want to have to measure it out, and it's like, why reinvent the wheel if I could download that model? Exactly,
and this is what we talked about in that first segment, which is if it's going to be a complicated design and it already exists, why rebuild it? Just use what someone else has done and make the modifications to make it work for your application.
Exactly. So I was able to then use this little platform for the suction cup mount that I have for the GoPro, and then put it on the motorcycle. So that's like where something like this is really handy to have a 3D printer around, is just these little applications for like, I would not have been able to mount that camera on my motorcycle otherwise. But I took the GoPro existing file for just that little piece, and then made a little platform, measured out the hole, and had just like a standard screw. I was able to use it with my suction cup mount.
You know, the funny thing about this is it's sort of changed the way that I start putting together projects, because it always used to be, oh, there's that one piece that I need, and I have to special order it. Oh, it's going to take another 3 weeks for us to get this on know-how.
Right.
Now it's, I wonder what Thingiverse has. What can I get and change to make it fit this, so that I don't have to wait the extra 3 weeks to get the special part?
Well, and it's like, well, for that camera review, I would have in the past probably just duct taped, back to the old duct tape.
There's nothing wrong with duct tape, but we wanted something more elegant.
Right, and the thing I love about Thingiverse, speaking of, is that when I did a search for the GoPro mount, there's just so many options.
Yeah.
So many people have already built this like gigantic library of things, and I was able just to, in the very first few searches, find this one and print it out for my motorcycle helmet, which I happen to have here. And so it's just this little cage that I printed out for the GoPro, and it's not as protective as the normal case, but it makes it so much smaller and lighter, and I can just put it here, and it's not as much as an obstruction.
So this is a mouth cam. This is the view from your mouth.
This is the point of view.
Yeah. Well, point of mouth.
Point of mouth.
It's not.
Should we have those for the show too?
Couldn't you just drive around with the camera in your mouth? I mean, right?
Do they have one that would fit in there? So.
Yeah, and again, this is what we're trying to really get into our audience's head, which is download it, break it, make it not work, and then figure out how you can fix the design. That's how we do things like this. This is how the world of fast prototyping works. This is ultimately what you wanted that 3D printer for. It wasn't to save money, because honestly, you don't save a lot of money because you end up printing so many different versions of what you were trying to create.
Right.
But what you can get is you can get something that exactly fits your needs. And you can, it's like having a store inside your room, and 5 hours later, you've got the part that you want.
Exactly, yeah. It's fun. And I don't know about you, but did you see some of the stuff Karsten was? He would sneak onto the MakerBot, and then I would come down there, and it's like, oh, a 47-hour print. What could that be? And it was a giant skull that he was printing that used up all the filament. So lock up your 3D printers.
We actually wanted to take that and improve it. We're going to put lights inside of it. But
I think he took it home.
He did take it home.
And we don't have any more filament. So.
Oh, I've got a lot of filament.
Oh, you got some?
I've got
all right, maybe we'll print another one and then LED light it up.
Filament.
Ooh.
Actually, I have glow-in-the-dark filament.
So you know what game I've been playing a lot?
Doom.
Doom. It's for the gaming PC review. We could do a Doom-themed skull.
I heard there's a vicious rumor going on somewhere that there's a Hal Grumple, that he is much better at Doom than you are.
I don't know how that rumor got started. It's certainly not true.
Excuse me, Padre. That's Alex.
Alex. I hear that Alex Gumple is way better than you, whoever he is.
I don't know who that is. Yeah. I've never heard of him.
Yeah. Alex, have you ever heard of him before?
Yeah, no.
Nope, no.
Yeah.
But he is better.
Wow.
He did find most of the collectibles.
Oh.
Except for 2. The first time through the game. Unlike a certain Bryan.
Hey,
it did help when that Alex Grumple was sitting next to me, pointing out, "Hey, you might have missed something," as you run by it.
Isn't that always fun? The backseat, the
backseat gaming.
No, was he drinking like a Manhattan as you? Oh, hey, Bryan.
Yeah, he was, and he had his pinky extended. He had like the smoking jacket on and everything.
Did he have the monocle and the bowler hat?
If you happen to go back about 5 steps, you might find something secret.
Actually, the reason why we were talking about Doom is because you need to stay tabbed, because coming up next week, we've actually got a gaming episode. We're going to be having Alan Malventano on to talk about SSDs, what you're going to want inside your gaming box. We've got your review of the Predator that we've had for 4 or 5 months now.
I had to do extensive testing.
Yeah, it's a great box, and we're going to show you why. And also, we've got some accessories that you might want to add to your gaming rig, but that's all coming up on a future episode of Know How. In the meantime, Bryan, I know this was a lot of material, and we want to make it easy for our audience to find our links, all the STL files that we used during this episode, as well as where they can get things like Mesh Mixer and Tinkercad.
Yeah.
Where should they go?
Well, they should go to twit.tv/KH, and they'll find all the links to everything we mentioned today. Maybe some links to our Tinkercad files, right?
Oh, yeah.
Yeah. I'll make mine public. Mine are all private right now.
And remember, folks, one of the things that we love is when you outdo us. That's awesome. When you can take something that we've created and turn it into something better, something
and then
that
make us feel bad about
it, and
then we put it on the show.
Do it. So if you've got a better idea for the straining device, make it, and I'll modify the titration machine so that it will work for it.
And if there's any DS owners out there, see if you can make a better stand, one that you can charge with the stand or something like that.
Yeah. Again, that's all at twit.tv/KH for Know How. That's not the only place they're going to find us. They're going to find us on Google+. We've actually got a community of over 10,000 people. Just go to Google+ and look for Know How. Join up. It is an approval because I had to get rid of all the spammers But I approve pretty much within a couple of hours. Anytime I see it. If you're worthy. No, but it is a great place to find ideas for new projects, to talk to people who are makers and hackers and DIYers. Or if you're an expert, it's a great place for you to give back to the community. If you want to help someone with a 3D printing problem that they're having, please do it. Or if you've got a project that you would love for us to show off on Know-How, put it in there. We'll try to get it into the show.
Absolutely. Or if you have a drone crash video, those are my favorite.
We like those. Those are just fun.
But that's not the only place you can find us online. If you want a behind-the-scenes look or follow what we're doing when we're not on Know-How, you can follow me on Twitter at cranky_hippo.
And you can find me at PadreSJ. That's at PadreSJ. And there is a third member of our team.
The director.
Yes, he's the guy who pushes all our buttons. He's the guy who keeps us on time. He is the guy.
Oh, I push your buttons.
Oh, yeah, yeah. Who drinks Manhattans and makes snarky comments at Cranky Hippo or Hanky Crippo while he's playing Doom. He is the one, the only Steven. Steven.
Oh, yeah, that's right. He didn't survive on, was it Ultra Nightmare?
Ultra Nightmare.
Yeah. So every time you die, it leaves a little gravestone of when you passed. Yeah.
Because if you die in Ultra Nightmare, you have to start over from the very beginning.
Oh,
right.
Oh, yeah, that's...
And I would recommend not having your director standing over your shoulder while you're playing Ultra Nightmare, because he'll make snarky remarks like, well, I didn't die 3 times right there.
So wait. In Ultra Nightmare, you can save as long as you don't die, right?
No.
Oh, you have to play the whole way through.
It checkpoints, but if you die, you go all the way back to the beginning of the level.
So as you're about to die, will you just like yank the power on the computer?
No, that's not going to help you. You're still going to die.
You're still going to die. How about that? Folks, that does it for this episode. Thank you very much for watching. Don't forget to check back next week. We've got 2 episodes every week, actually. We've got, on Monday, we're going to be finishing up this section of the podcast series that's all about mics. So you're going to want to drop in. And next Thursday, we've got another 3D printing episode. We're going to show you some advanced troubleshooting techniques. I know that some of you with 3D printers out there have issues. We're going to show you how to fix it. But until next time, I'm Father Robert Ballecer.
And I'm Bryan Burnett.
And now that you know how,
we'll build it.